from last class, we said that we would be doing math today, and that is correct. Don't worry, I'm not going to pull another switcheroo on you, even though I'm pretty sure maybe some of you might have appreciated that. But we're going to be going back to math now, and we are going to start off with a little review quiz. Now, this quiz, it's based on topics that we did like just last class only. So I think I'll give you guys 4 minutes to do this starting now. It should serve as a good warm-up. All right then, everyone, 4 minutes are up. So let's come back and check out these questions. So our first question, or at least our first 2 questions, are talking about a bunch of frogs that are living in different environments. It should be pretty simple, honestly. First question, how many non-red frogs live in the forest and wetland? So that means we are not looking at the red area. We are only going to be focusing on the forest and wetland, so we're not looking at the desert. That means we are only looking at that part of the data set. So 150 plus 50 plus 90 plus 60, that should be 350. Now, number 2. This one, I actually put a little bit of a trick in here to make sure that you read the question properly. So a calamity wipes out 50% of the red frogs in the desert. So if we just clear that data set so that we can change the numbers a little bit. Okay, the red frogs, they got cut by 50%, so that's now 35 of them in the desert. 90% of the blue frogs in the wetlands. Note how it says wetlands, not the desert. That is important. So 90% of the blue frogs in the desert. So that would leave 9 frogs there. And then 40% of the green frogs in the desert. So 40% of 200 is 80, so that's going to be 120 green frogs. How many frogs are left in the desert? Well, 35 plus 10 plus 120. We're doing plus 10 because these guys over here, they are fine. They're just fine. They didn't get affected by anything. Make sure you don't read the question too carefully, or else I imagine some of you might have accidentally applied the 90% part to this, and then you would have said, oh, there's only one blue frog in the desert, and you would have said the answer 156 instead of 165, which is the correct answer. Okay, next question. Which of the following is equal to 12x squared plus 12x plus 3? Now, you could do the option, or you could do the method where you just expand every single option choice. I would prefer to work backwards and condense this equation as much as I can, because if you know the patterns, then you can condense equations really easily. So it's kind of obvious that 3 is a common factor in every single one of these terms. So we'll just factor 3 out if my annotate works properly. Yeah, okay. We'll factor 3 out, so 4x squared plus 4x plus 1. I recognize a pattern here. This is an a squared plus 2ab plus b squared type of equation, and that can turn into a plus b squared. So if we condense this, that turns into 3. The a in this case will be 2x, and then the b in this case will be 1. That was a bad one, but you kind of get it, right? Yeah. So 3 times 2x plus 1 squared, that matches with answer C. Excuse me. Okay, next question. We need to find the values of a and b are embedded in this equation. Pretty much all we have to do is expand that equation, multiply them by each other so that we can match the terms together and then find a and b. So if we expand it completely, 3x squared times bx is going to be 3bx oh no, not x squared, it's going to be x cubed because that's 3x squared times x, right? So 3bx cubed and then 3x squared minus 4x, so it's going to be minus 12x squared, and then a times bx, that's going to be abx, and then minus 4a. Now this should be pretty easy because I'll color code it to make it easier. 3bx cubed corresponds over here, so we can find b easily, and then negative 4a corresponds to that term. So 3b is equal to 15, or let's start with the a. So negative 4, actually no, we don't need to put the negative there. We can just say 4a is equal to 16 because it's negative in both. So a is equal to 4. And we don't even have to find b because only one option has a equals 4, and that's d. Now the last question, this is a that question type, if you remember, where we're looking at populations and parameters, and we need to make sure that we make the correct statement, make it so that it's as specific as possible, but not to the point where we're making statements that we're not allowed to make. For example, we can't say that we believe every single product in the whole lifetime of the company's production is like our condition if our sample only occurred on one day and we didn't track the entire company's lifespan. So in this scenario of a violin company, and ever since they first started producing, this is an important one, ever since they first started producing, every day a machine checks the length of 20% of the strings. So it is taking a sample. So it calculates that it has an average length of 32.5 centimeters with a 0.5 centimeter margin of error. So that means our margins are going to be 32 and 33. Not like you need to figure that by yourself anyway, because the option choices tell you that. Which of the following statements is true? So I just want to make it clear, do not default to saying it is plausible every time, because there will be times on the question where you could say all of, or you can make big generalizations if the situation calls for it. In this case, A and B say it is plausible that, now the thing is that for A, it says made on one day, whereas for B, it says made in the company's lifetime. For C, it says during a month of production, and then D says made in the company's lifetime. Now, they say that since they first started producing, every day a machine has been checking the lengths, right? So we're actually allowed to go up from just one day all the way up to the entire company's lifetime. So that means that the option choice is probably going to be either B or D. Now, B says it is plausible that all the strings in the company's lifetime are between 32 and 33, whereas D is definitively saying that all of the strings have this length. So which one do we need to pick? Now, actually, in this case, we should pick B, plausible. Why? Because we are only checking 20% of the strings that were made by the factory every day. We're not checking every single string. So even if it's even if it's pretty accurate, we can't be 100% sure. So I hope that went well for most of you. There were a couple of tricks in there, but hopefully they shouldn't have tripped you up too much. And if they did, I hope I explained them well enough. Yeah, okay. Okay, the quadratic formula. This is one of my favorite parts of algebra, which, okay, kind of sounds masochistic to some people, but don't worry, it's actually pretty cool. So let's take a look at the question. What are the solutions to x squared minus 3 is equal to x? Now, the thing is, if you tried solving this equation, let's try first expanding it so that we have all the terms on one side and then 0 on the other side. We would get x squared minus x minus 3 is equal to 0. And the problem with this equation is that I can't use my normal methods to figure out the answer. I like doing the butterfly method where I take a look at the factors of each of the terms. In this case, for x squared, it's going to be 1, 1, and then for 3, it's going to be 1 and then -3, and you have to come up with cross combinations and add them up so that they're equal to the middle term. And in this case, I can't do that. And actually, it's impossible to solve this question with a conventional or normal method that people, or at least high schoolers, would know. So in this case, if you get something really weird or a weird quadratic, you have to use the quadratic formula. And the quadratic formula is the formula down below. Oh boy, what happened? Okay, we're back. So about the quadratic formula, you should be able to memorize this because while in the SAT they will provide the formula to you, you don't want to be referring to it all the time because don't forget the SAT might be digital in the future, so it could be kind of cumbersome to keep on having to click and reopen it. For paper takers, it's even worse because you have to flip to the front of your booklet and then back, and you have to like memorize the whole thing while you're flipping. So you should practice this on your own. And the quadratic formula is as shown below. X is equal to -b plus or minus the square root of b squared minus 4ac over 2a. And what the variables mean in this case is that they're referring to different coefficients on the quadratic equation. Quadratic equations are typically formatted like this: ax squared plus bx plus c. And this is that's pretty much how every quadratic equation can be formatted. For example, if you got something like 9x squared plus 8x minus 2, then a equals 9, b equals 8, c equals -2. And then if you got something like x squared minus let's say 5, then we would say a is equal to 1 because you could put a 1 there as a coefficient. B would be equal to 0 because there is no b term where there's like an x in the middle of the equation, and then c is equal to -5. Some people are asking about discriminants. We'll get into that later. They might be of some kind of use later on, but for now they won't be necessary. So all you need to do with the quadratic formula is just identify what A, B, and C are in your equation, and then just plug the numbers into the formula. So I'm going to clear the board, and we're going to do that right now. So let's rewrite the equation: x squared minus x minus 3. So A is going to be equal to 1, and then B is going to be equal to -1 because the middle term is -x, so that's like a -1 over there. C is going to be equal to -3. And if we plug this all into our formula, we will get x is equal to -1 because that's a -b there, remember? So we have to put that in parentheses so that we can properly apply it. Plus or minus the square root of b squared, so -1 squared minus 4a, a is 1, and then c is -3. And then all of this is over 2a, which is going to be 2 times 1. And then if we solve the entire thing, we will get +1 plus or minus plus or minus the square root of +1 plus 12 over 2, which is 1 plus or minus the square root of 13 over 2. And D will be the answer that matches up with that. So it is a pretty long and complex formula. I do highly suggest that you practice with this and that you memorize it yourself. Pretty much every high-level algebra student memorizes that religiously. And yeah, even though they will give it to you on the SAT, I still suggest you memorize it yourself. So here are some questions. I'm going to give you guys 3 minutes to do these starting now. They shouldn't take you too long. Yes, Mahit, do you have a question?
Yeah, I don't think they actually give it to you in the booklet.
What booklet are you talking about?
I don't think they give the formula on the reference guide in the test.
Well, when I took the SAT, they did. They might have changed it now. I'm not surprised if they took it off now because they probably want students to remember it anyways.
Yeah, that's what because I didn't see it.
All right, everybody. So 3 minutes are up, and actually they were up a little bit of time ago, but I had to take care of something a little bit on my end. Hopefully you guys are able to answer them all without any problem. I'm only going to do the first one with you guys, and then I'll just provide the answers for the other ones. Yeah, where's my pen? Okay, yeah. So for the first question, if you notice, the question is not saying it is equal to 0, so we need to make it so that the equation is like that. So all we have to do is just subtract 5 from both sides, and then we'll get 2x squared minus 3x minus 20. And then if we just apply the quadratic equation, we get 3 plus or minus 9 plus 160 over 4, which is equal to 3 plus or minus square root of 169 over 4. Now, the cool thing about this is that you can actually go further. Most of the time when you're using the quadratic formula, students will tend to leave the answer just as it is over here. But if you notice that the square root can be simplified, then you can actually get a rational solution. So square root of 169 is actually equal to 13. So we can do 3 plus or minus 13 over 4, which is equal to 16 over 4, comma, negative 10 over 4, which if we simplify even further is equal to 4, comma, negative 2.5. So yeah, just wanted to put that out there. You can simplify it even further sometimes. I'll put the solutions back here, comment, yeah. Okay, for the next question, the solution, if you simplified it, should have been negative 7 over 2, comma, negative 1. And then for the next question, this one was a little bit of a mean one. You really shouldn't have been able to simplify this past the square root. It would be negative 4 plus or minus 592 over 18. And then, yeah, it pretty much just follows. We have some questions. Arya, you have a question?
Yeah, so I was wondering for the first two, can you just like factor or normally?
Oh, yeah, absolutely. If you can factor normally, then you should factor normally because honestly, that takes way less time. And the quadratic equation should be reserved for questions where you genuinely can't figure it out normally or it's way too complicated for you to do so.
Okay, thank you.
No problem. We are going to look at a couple of logic problems. So for the first question, they put us with a condition initially, which is that x cannot, oh wait, so they say that x has to be greater than 0. Now, oh boy, yeah, navigating the toolbar is kind of hard on a single screen, but okay, x has to be greater than 0. That means x can't be lower than 0. The thing is that this quadratic equation might actually give us a couple of negative answers, so we need to be careful of that. If we factor this normally, I'm just going to factor this doing the butterfly method. I'll try explaining it as best as I can. Basically, the butterfly method is where you look at the coefficients. That was not a good underline. You look at the coefficients of the first x squared term and the last c term, and then you break them up into coefficients that when you multiply and add them together, their sum will be equal to the center coefficient. So something I recognize here is that we have a 2 and then a 2. And then we also have a 1 and a 1 because, well, 1 times 2 is equal to 2. And then we can do 1 times -2 or -2 times 1. And one of those combinations of additions and multiplications should yield us a sum that is equal to 3. Now, this does take a little bit of intuition and just a whole lot of practice. There's no really there's not any big trick to figuring it out, but I can sort of feel that the negative would be better spent on the -1 than the 2, because if we cross multiply these, then we get 4, and then we get -1, and then 4 plus -1 is equal to 3. Now, that means since 3 is equal to the center coefficient, that means that our current configuration works. So let me just erase the middle over there. Now all I have to do is add an x to the terms on the left. So because there's just a 1 on top, we're just going to make that an x. And then for the bottom, it's going to be 2x. These will be our new factored equations. So the equation that we had over here is going to be equal to x plus 2 times 2x minus 1. Now, what are the solutions to this equation? Well, if we set this equal to 0, then all we have to do is say, we can split it up into like 2 parts and say, okay, what if we set x plus 2 is equal to 0, and then 2x minus 1 is equal to 0? X plus 2 is equal to 0, that means x would equal -2. Then 2x minus 1 is equal to 0. Let's move the 1 over here, and then we divide both sides by 2. We get x is equal to 1/2. Now remember, they say x has to be greater than 0, so that means we can't do x is equal to -2. So that answer gets crossed out. B will be the correct option because that has the answer that we need. You guys don't have to worry about improper form or standard form when it comes to fractions, because it's all going to be multiple choice anyway. They're going to provide you with the answers. Surya, do you have a question?
Oh no, I just forgot to lower my hand.
Oh, okay, no worries. Okay, now for the next problem. Oh yeah, by the way, if you're still confused about the butterfly method, I really don't have anything to tell you. You're gonna have to look that up online. I'll see if I can find a good video and I'll post it in the WhatsApp group. But for now, we have to keep moving on. Okay, next question. This has squares, or at least exponents, which can actually be kind of tricky when you're dealing with exponents equal to exponents. So they're asking, what is the sum of the solutions of this? Now, a lot of people's first instinct is to do, okay, what if we just square root both sides? And that can work, but there's one thing you need to remember. When you say, let's take an example. Okay, x squared is equal to 4, and you square root both sides, then you need to apply a plus or minus to the right side of the equation, or whatever side of the equation that you're trying to put the numerical value in. So the numerical value is on the right side, so we're going to put the plus or minus on the right side. So this is going to turn into x is equal to plus or minus 2. And I'm pretty sure I don't need to explain why we need to do this, because when you're dealing with squares, the negatives kind of get canceled out, because if you have -2 squared, that's equal to -2 times -2, which is 4. So you end up with a positive answer anyway. That means you need to do the same thing in this case. Now, because there's an x on both sides, what you need to do is you just need to take the plus or minus and put on either side. It should work. I'm just going to put it on the right side again. So if we square root both of these sides, we get 2x minus 1 is equal to plus or minus x plus 2. Now we're going to split this into the positive version and the negative version. So the positive version is going to go like 2x minus 1 is equal to x plus 2. If we shift everything around, so minus x, and then plus 1, then we're going to get x is equal to 3. Now for the negative side, we're going to do 2x minus 1 is equal to negative x plus 2. And that is going to turn into, first let's actually expand that. So that's going to turn into negative x minus 2. And then we add x to both sides. And then we add 1 to both sides. Then we get, sorry, it's a little bit cramped, but the final answer will be 3x is equal to negative 1. And then we just divide both sides by 3, we get x is equal to negative 1 over 3. That's one solution. That's our second solution. And then they ask, what is the sum of the solution? So we do 3 plus negative 1 over 3. 3 is equal to 9 over 3. So 9 over 3 minus 1 over 3. That is going to be equal to 8 over 3. So the correct answer should be A. Now, another way you could have is by simply expanding both sides of the equation. So that on the left side, you would have 4x squared minus 4x plus 1. And then on the other side, you would have x squared plus 4x plus 4. And then you would subtract from both sides and you would just solve the resulting equation accordingly. But it just depends. You can select either way to do it. And yeah, that's pretty much how you would go about this. Remember, when square rooting, you need to apply a plus or minus to the other side. Mahit, do you have a question?
Yeah. What I was thinking of when you were taking the square root, I mean, yes. But don't you also have to re-include the squared again? Because if you're doing a square root, then you have to redo put a square in there as well.
Not exactly sure what you mean, but if you square root the square, then it just neutralizes and becomes a normal equation. So,
what I'm saying is when you take a square root, right?
Yeah.
Here you just have this regular equation as is, and then you decide to take a square root of it. But then don't you also have to reapply squaring it again?
No, you don't. You don't. Because we're applying it to both sides, then nothing is really changing in the grand scheme of things.
Okay, that clears things up because I always thought because when you're putting in the square root and then you put the
It's
square,
okay. It's okay. You
different
don't have to
because they're
justify
inverse.
it. It's okay. You don't have to
They're
justify
inverse, so
yourself,
that's
dude.
why I'm just curious. Okay, thank you.
No worries. Usha, you have a question?
Yeah, I was wondering if I could switch the x plus 2 squared onto the other side first before square rooting it, or would that get me a different answer?
I feel like that would definitely get you a different answer. Because the thing is, what you would be saying is that would be like doing x squared plus y squared, and I bet what you're thinking in your head is that would be equal to x plus y. Am I correct? That's what you think it would be equal to?
Yeah.
That is not true. That is actually not true. It would be equal to something completely different that you can't solve like this. So yeah, doing that would jeopardize the equation.
All right, thank you.
Don't worry. Okay, this next question is kind of a doozy. You have to read it quite deeply. So we have a car. It's traveling at x feet per second. So x is the velocity, the speed. The driver sees a red light ahead, and after 1.5 seconds of reaction time, the driver applies the brake. After the brake is applied, the car takes x over 24 seconds to stop. So it takes him that long to stop. We don't exactly know how long because we don't know x yet, but it's important. And the average speed of the car is x over 2 feet per second. So that's like a new velocity. If the car travels 165 feet from the time he saw the red light to the time he comes to a stop, which of the following equations can be used to find the value of x? So we need to find the value of x, which is his speed before he was trying to stop. Now, how do we do that? The thing here is that you need to look at this from a real life scenario. So in real life, how is distance calculated? Distance is equal to velocity times time, correct? So we could say that we need to find basically the time between, or at least how long it took for him between the time he saw the red light to the time he came to a complete stop. And he sees the red light, he doesn't change his speed for 1.5 seconds. So in this case, x is going to be our velocity, and then our time is going to be 1.5. So let's write that out. Oh wait, I should put the 1.5 first. Yeah. 1.5x. This is talking about the time where he doesn't slow down. Now, when he does slow down, he gets a new distance, or sorry, he gets a new velocity and he gets a new time. They say that after the brake is applied, the car takes x out of 24 seconds to stop. So let me just erase the bottom here. So in this case, our new time is going to be x over 24. And then they say the average speed of the car is x over 2 feet per second. So our new velocity is x over 2. So if we add that to the previous equation and we multiply them together, we get x squared over 48. So this is how far, so the first part is how far he travels when he doesn't slow down. The second part is how far he travels when he does slow down. And then both of those times combined, they're going to give us the total distance he traveled. And they tell us he traveled 165 feet in total. So we can set this equal to 165 feet. You guys with me? So we actually do have a quadratic equation here. All we need to do now is split it up. Or sorry, not split it up, but properly, just expand it out. So if we do that, how do we expand it out? Well, in the options or in the answer choices we see, we have x squared, x squared, x squared, x squared. That means that they want us to turn the x squared term into something that doesn't have a denominator. So we need to get rid of this denominator. How do we do that? We multiply the entire darn equation by 48. We do that, we get x squared, assuming that you're rearranging, of course, the x squareds in the beginning. And then 48 times 1.5x is going to be plus 72x. So that means we can already eliminate answer choices A and B. And then lastly, it's going to be minus 7,920. Yes, because 165 times 48 is 7,920. That is going to be your final quadratic equation, and D is the correct answer. Now, that was a pretty challenging question. Even I was a little bit stumped, like for the first minute when I took a look at this. But what you need to do is you need to think in real term values and need to think about like, velocity. You see how we figured out that we need to measure the distance, right? And that there's like two parts of it, where there's like the part where he doesn't slow down, and then there's a part where he slows down. Those have different distance values. For the part where he doesn't slow down, we know that the time is 1.5 seconds, so we already have the time as like a discrete number there, and then he's traveling at x feet per second anyway, so we just say 1.5x for when he doesn't slow down. And then for when he does slow down, he gets a new velocity, which is x over, which is x over 2 feet per second. Then he gets a new time, which is x over 24. So we use those new values to create the second part, and then we set it equal to 165. Okay, yeah, some of you are definitely concerned about whether or not you would be able to use a calculator on this. Unfortunately, this would be considered a non-calculator type question. And while that can seem a little bit scary, there really is no reason for you to use a calculator. If anything, using a calculator would probably make it so that it would take longer. I can't really see how using a calculator would make this faster. Don't worry, you guys. Just because the problem is complex doesn't mean that you should use a calculator. A lot of stuff on your own, where a calculator is not going to have, at least in my opinion, such as a question like this, then you should be able to handle it by yourself. Okay, so here we have a little mini quiz. Now I'm going to give you guys 4 minutes to do this starting now. Don't worry about the last question. You don't have to worry about that because I did some content rearranging. We're going to deal with exponential manipulation much later in this slideshow. So yeah, for now, you don't have to do that. You can take a shot at it if you want, but we won't be going over it. Also, if you missed something out, or if you like zoned out for something, unfortunately, I can't accommodate you because that's only one person. We have like quite literally 200, 300 people here to move forward with. So yeah, tough luck. There might be a recording as far as I'm aware, so maybe that'll get released. I don't know. All right, everybody, 4 minutes are up, so let's come back and check out these questions. Phew, now, hopefully you had enough time to do the quadratics and the two bottom questions, but we'll be going over them now anyway. So the first one should be pretty easy. I'm just going to provide the answers because most of them more or less just use the same method that we already know. So for this one, r is going to be equal to plus or minus 4. For this one, m is going to be equal to 7 plus or minus the square root of 73 over 4. For the next one, that one's pretty easy. X is equal to -1 and -3. And then for the last one, this is a kind of a nasty one. It's equal to -7 plus or minus square root of 305 over 16. Now, the next question, they say x is not equal to 0. And then they ask, what is the product of the solutions? So we need to find the solution of this quadratic. There's an x in every single one of the terms, so we can factor an x out. And I noticed that I can use the butterfly method here actually, because there is a multiplication addition pair that can work here. So we have 1, 1 for the x squared, and then we have 9 and then 3 on the right side. If we put the negative to the 9, cross multiply, then we get -9 and 3. If you add those together, that becomes -6, and -6 matches with the middle term. So that means we have the right configuration now. So that means that it's going to be x minus 9 times x plus 3. And then we put the x on the end for good measure, because remember, we still have the x we factored out. So the solutions to x are 0, -3, and 9. Now, the thing is, if you took the product of these solutions, you would get A, but they said that x cannot be equal to 0. So we have to disregard the 0, and then we instead do negative 3 times 9, which is going to be negative 27b. Now, the next one, you can do a little something where you square root both sides by a factor of 4, and then you end up with the equation 5x minus 8 is equal to 2. The way this works is that 2 to the power of 4 is equal to 16. And then if you go backwards, but basically what we did is like a reverse exponent. That's pretty much what roots are anyways, if they're like reverse exponents. And remember, because this is an even square root, we have to put the plus or minus. So then, all in all, you should end up with the answers of x is equal to 2 and x is equal to 6/5. And then the sum of the solutions would be D. Now, the last question, you guys didn't have to do that, but if you wanted to, then the correct answer would be A. Okay, now we are going to actually talk about exponential models, but before we do that, I'm just gonna take a little bit of sip of water. Oh yeah, that's right. I got one of those big bulk water bottles that are like as big as your entire abdomen. But anyway, let's take a look at this question. Okay. A researcher estimates that the population of a city is increasing at an annual rate of 0.6%. If the current population of the city is 80,000, which of the following expressions appropriately models the population of the city T years from now? So I'm going to give you guys the formula to the basic exponential model, and I'm going to choose a better color, black. Okay, it's this. Y is equal to A times B to the power of X. Now, what do each of these terms mean? Okay, so A, man, maybe I should choose a different color. Okay, red. Forgot that using clear all deletes everything. Okay, so A, this is going to be your starting population, your starting amount. B is going to be your growth or decay factor. What this means is B is the value that is going to control how fast your population grows or how fast it decays. X is the variable that you're inputting. It is going to be a unit of time, usually. In this case, X is going to be years. And actually, in this case, X is going to be T according to the question. Now, the thing here, I want to make something clear. When it comes to growth, when you have a starting population, that starting population is at 100% of its value, and 100% is equal to 1 in decimal terms. There are too many people who think that a population at its base is equal to 0%. That is not true. And what happens is any additions you make to 100%, for example, if you said, okay, I have a population and it has increased by 10%, then your new population value, or how many units are in your population, is now equal to 110%, which is equal to 1.1. Now, the reason this is important is because there are actually 4 aspects to the exponential model, and that is shown over here. This 1 that you see over here represents the population's base. And then the plus, whatever is over here, represents that the 100% is having something added onto it, which signifies growth. Now, if this was, say, if this plus was, say, a negative instead, then it would be considered a decay factor because it would be something less than 100%. So if B is less than 1, then it is decay. If B is greater than 1, it is growth. Now, we need to take a look at the options and figure out which option exactly matches up with the model. So good news is that everything starts out with 80,000, so the starting population is fine. Now, the problem is with C, there's no parentheses. There's like no nothing. What's happening is you're adding 1 to the population. You're not multiplying by the percent. That would be like taking 100 and instead of multiplying it by 6%, you are adding 6%, which is actually it's like virtually useless. That does nothing. So C is wrong. D. Some people might have picked D because they did the same error where they assume that 0% is like your start, which is wrong. They say they look 0.006. Oh, that is equal to 0.6%. What they don't realize is that you need to take 0.006%, and since it's a growth, you need to do 1 plus 0.006. So D, this is actually representing a massive, massive decay, which is the opposite of what we want. So D is wrong. Now, A versus B, some of you might be confused. What's the difference between A versus B? Well, B has T on the inside, whereas A has T on the outside. This is very important. T needs to be on the outside. It needs to be on the outside of the B. Or at least it should be on the outside of the parentheses of the growth/decay factor. So A is wrong. Oh, sorry. B is wrong because T is on the inside. A is the correct answer. Okay. So this is a nifty little question. And I am going to give you guys 3 minutes to solve this on your own. See if you can solve it before 3 minutes without any of my help. All right, everybody, 3 minutes are up. So let's come back and check out this question. Before I get started, Tejas, do you have a question?
Yeah, I have a question. So when the exponent is negative, is that counted as decay?
No.
Exponential
Well,
function?
yes, it does become a decay, not in the way that you think, though. I'll explain it. That was a good
Okay.
point you brought up.
Okay, thank you.
No problem. Okay. So with this question, they're asking which of the following functions best models the number of bacteria. So what is the model? It's y is equal to a times, you know what? I'm not going to say b. I'm going to do 1 plus y and then to the power. Okay, actually we can't use y because we already have a y. What should I use? I'll just use d. So y is equal to a times 1 plus d to the power of x. Now, in this case, it's actually pretty simple, and actually the previous model works a little bit easier. You can think of b not as percentage increase or decrease, but you can also think of b as how much something was multiplied by. And that is going to be handy in this case because, first of all, let's get this out of the way. A is going to be wrong because that's not an exponential equation. That is a linear equation. Same thing for B. That is not an exponential equation. And even though it has the 1000 starting point, that is just, yeah, that's just linear. Now C and D. Now I'm pretty sure that it's not that hard for you guys to tell which one is the correct answer. It's going to be D. Now, I know what you're thinking. Hasu, didn't you just say that the T can't be inside? Well, what I meant was that applies to this type of equation, where if they format it like 1 plus something, and then they take the x and attach it to the d, that is wrong. That is bad. But if you just have this and you just have like a number b chilling out there, it doesn't matter if x is directly attached to it or on the outside. And most of the equations they give you will be in the second form anyways. So if you recognize it as the second form a times b to the power of x, then it's okay for x to be attached directly to the b. Now, remember how I said b is equal to how much something was multiplied by? So we're dealing with the population, right? And as you can see, it is clearly it is clearly multiplying by 4 each time, right? So that simply means our b value is 4, how much something was multiplied by. You can also interpret b as how much something was divided by. If you were to say, before we go into that, let's talk about C for a second. What C does is, because that is a negative exponent, if you didn't know, what happens with negative exponents is that, you remember how when we were doing perpendicular lines, we touched upon the topic of reciprocals? If you have a negative exponent, then you can turn that into a reciprocal while making the exponent positive. I'll give you an example. If you have 2 to the power of -1, you can turn that into a reciprocal version where the exponent is positive, but now the 2 sort of moved down to the denominator. What's going to happen here is that the negative in this case for C will cause the 4 to turn to reciprocal. So then option C will turn into this. Where it's going to be 1 over 4. And obviously that is wrong because that is a massive decay factor, not a growth factor. Usha, you have a question?
So disregarding the reciprocal point that you made, would
Yeah.
it make sense that because t is time, like time can't be negative? Would that also be a good way to go about it?
That is a good logical point. Like, that kind of makes sense when you're thinking about in the real world. However, I wouldn't rely on that too much because there are ways to take real world units and then make them negative in equations where in real life they don't make sense, but in the mathematical equation they will make sense. So if you do that trick, then you could get tricked by an equation that actually works, but you thought it didn't because that doesn't make sense realistically. So yeah, the answer to your question is basically no, unfortunately. You can't assume that because t is negative in option C and that time can't be negative, that C would be wrong. Phew, okay. So now this question, I made this one pretty tough on purpose. I'm going to give you guys 3 minutes as usual to figure this one out. Remember that the growth units, the years, t, is not normally represented in the data set. And the question is asking which of the following exponential functions does not represent the growth of the otter populations, which means, ironically, that 3 of these exponential equations will properly represent the data set. You have to find the one that doesn't do it right. All right, everybody, 3 minutes are up. So let's come back and check out this beast of a question that can be kind of tough if you don't know what you're doing. So, okay. Like I said, we need to figure out which one of the following functions doesn't work. Now, the thing here is, I might have confused you guys on purpose. No, I definitely confused you guys on purpose, where you're going from 100, 300, 900, 2700, and you're thinking, oh, it's a growth factor of times 3. B is equal to 3, right? No, B is not equal to 3. Because if you look, the units have been cut in half. They go from 0.5 to 1. So actually, you need to be looking at it like this, 0 to 1. If you go from, let me erase that. If you look at it from that way, then it should go more like this, 100 to 900, 900 to 8100. That is times 9 effect right there. So option B is out of the question because it has the correct starting position, it has the correct B value. Now, what about A? You might think, oh, well, it's got to be A, right? A is the one that doesn't work because it has the B value of 3? No, because if you look here, the units are in 2t. And this 2 over here, if you apply it to the 3, then this actually turns into 100 times 9 to the power of t. Yes, you can do that. If you have an exponent that has a coefficient and then a variable, you can take the coefficient, apply it to the number while keeping the variable up there. Okay, now some of you guys might be thinking, okay, then it's maybe C, right? Because it does have the right B value, but it starts at 900 instead of 100. Well, if you notice here, it says T minus 1. So that means that it's starting a year behind, or rather, it's starting a year behind to compensate for the fact that its starting value is 900. If you inputted the year values into this equation C, you would get the correct otter population. I'll give you an example. If we took year 1 and inputted it into C, it would be 900 times 9 to the power of 0 because, well, this was basically 1 minus 1. And then anything to the power of 0 is equal to 1. So then you would just end up with 900. And 900 is the correct value for year 1. You try this as any other year value, such as 2 or even 0, it's going to work. So it can't be A, like we said, it can't be C, it has to be D. Why? It has the correct starting value, but like we established, the proper B value is 9, and in this case, they put 3, and they didn't modify T, or that's not even pointing at T. They didn't modify T in any way to compensate for it, like how A and C did. So D is the correct answer. Oh boy, okay, even more practice. Man, I don't remember putting this many practices in here. Okay, I'm going to give you guys 3 minutes as usual to do this starting now. Apologies for the many practices in a row. I spent some time like reformatting everything, and maybe I put a little bit too much density in the exponent section. But hey, more work, more content, more value for your money. All right, everybody, 3 minutes are up. Let's come back and check out these questions. Oh, whoops. Okay. So, question number 1, if you're not aware, a half-life is basically the amount of time it takes for a compound to decay at least half of its mass. So what this means is, in this case, the 100-gram sample, after 7.5 days, 50 grams would be remaining. So if he leaves it out for 30 days, what percentage of the isotope will have degraded? So in order to do this, We need to figure out how much of the isotope was left by 30 days. So 7.5 days, and then we have 30 days in total. That's like 4 cycles or 4 units of 7.5 days, because 7.5 times 4 is equal to 30. So that means it is getting cut in half pretty frequently. So let's start at like day 0, he's at 100. 7.5 days, he's at 50. 15 days, he's at 25. 22.5 days, he's at 12.5. And then at 30 days, he's at what is it? Yeah. Wait, no. Okay. 6.25. So he's at 6.25 grams by 30 days. That is really low. So how much of it went away then? So 100 minus 6.25, that is around 94% according to my calculator. Now, 94% of it went away. There is no 94% here. Sometimes on the SAT, they will trick you by not providing the exact answer. What you need to do is you need to choose the closest answer. Option C will be the correct answer in this case. Now, how do we represent the model? We start with the 100, which is what we have. And then the thing here is that, okay, A and B are actually both wrong. Why is that? That is because the unit n days, we need to properly transform it so that the halving of the sample happens every 7.5 days. If you do n divided by 7.5, that is equal to 1 half-life cycle for this radioactive isotope. If you guys are combining units like this, or if you have like an arbitrary unit like 7.5 days, it can be helpful to take the unit that was provided to you and then, divide it by whatever that arbitrary unit was. Now, some of you might be thinking, oh, well, the answer has got to be D, right? Because if it's a half-life and it's decaying, then that's minus 50%, right? So then it's got to be at 50%, which is equal to 0.5, which is equal to 1/2, right? No. Here's the problem. If you notice, both C and D have negative exponents. And what did we say about negative exponents? It's that they cause reciprocalization. So if we apply the negative to the 1/2, that actually turns into 2. And that is not what we want. C is going to be the correct answer because it has the right unit or time unit, and then the negative, it will apply to the 2 and then turn into 1/2 to the power of n divided by 7.5, which is exactly what we want. Now, the third question, we need to find the function that models how many fields are left, D days after the epidemic. So this epidemic, first of all, we start with 700,000 members. And then with this population, however, 40% of the population is immune to the parasite. This actually makes the question really easy. You want to know why? If D represents the amount of fields left and 40% of the population is immune to the parasite, then that means 40% of them are not going to die no matter what. So you know what that means? We have like an extra factor where originally it would be A times B to the power of X, but now it's going to be A times B to the power of X plus C. And C is the part that is unaffected by the decay factor. So that means that what is 40% of 700K? That's 280K, right? And what answer has 280k just set aside to the side where it's not going to be affected by the decay factor? That's going to be option D. D is the correct answer. I'm going to go over the other options just so that you guys understand. It's not option C because option C is basically D, but it's missing the extra 280,000 seals that weren't harmed. C is only accounting for the seals that are being affected by the pandemic, whereas D is accounting for every seal, both the ones immune to the pandemic and the ones that are not immune. A and B, they are wrong because the answers basically forgot that there is an immune population. If there wasn't an immune population, then option B would probably be the correct the correct answer because it has the right base and it has the right decay factor. A is the most wrong answer because it has a growth factor instead of a decay factor. So it's just not representative of what we need. Okay, so we are finally going to get into exponential manipulation, which can be a little bit of a hairy subject. So there's two things I want you guys to know that some of you guys, or most of you probably already know. So this is our friend x. This is an exponent. And then this is our friend x again, but he is getting square rooted. So did you know that how when there is a plus and a minus that are opposites to each other, exponents and square roots are also opposites of each other? And actually, square roots have a different way of being represented. The square root of x is equal to x to the power of 1/2. You see, it was an exponent all along. Square roots are just fractional exponents. You ever see exponents sometimes that have a little symbol, like a little number that they're marked with above the jagged area, and then they have like a number that can be cube rooted. This is what we call them, cube roots, because three sides, cube, and that would be equal to 3, and that is also equal to 27 to the power of 1/3. Now, how is this going to help us? It's going to help us with this. So in order to figure out which of the following is equivalent to the equation they gave us, we need to simplify as hard as we can. First order of business, we need to get rid of the square root. So square root of x, we already established, is equal to x to the power of 1/2. So if we rewrite this, it is equal to 1 over x to the power of 1/2 to the power of 9. Now, what we need to do is we need to get x to the top, to the numerator, because as you can see in all the options, x is not on the denominator. It is a numerator. In order to do that, we are going to do reverse reciprocalization, right? Do you remember how when we did something like, if we did 1 over 2 to the power of -3, and in order to get rid of the negative exponent, we would put the 2 to the top, so we would reciprocalize it, and then it would be 2 to the power of 3. So we all know that fact, where when you reciprocalize an exponent, the exponent changes sign. We're going to do the opposite, where we're going to go from positive to negative. So 1 over x to the power of 1/2, we are going to reciprocalize it. So we're going to bring this up here. That is going to be equal to x to the power of -1/2. And then we have this exponent n. We can't forget that. So we're going to attach that right there. And now here is a law that you guys should know. X to the power of a, and then that x to the power of a to the power of b. In a situation where we're nesting exponents like this, x is equal to the power of a times b. So in this case, this is going to be equal to x to the power of negative n over 2, because, well, negative 1/2 times n is negative n over 2. So that will be the correct answer, and B is going to be the correct answer. I just introduced a couple of laws to you, exponent laws. Now get ready. There's a whole lot more. These are a whole bunch of exponent rules and laws that you guys should know. Maybe save for the last one, but even the last one can be pretty useful sometimes on the SAT. So I'm just going to go over these laws with you guys quickly. So the product rule is a to the power of n times a to the power, that should be an n. Yeah. Basically, when you're multiplying two exponents with the same base, you can add their exponents together. For example, if you're doing 2 to the power of 2 times 2 to the power of 3, you can add the exponents together. Now, the quotient rule is division, and that is going to do the opposite of the product rule, where if we have 4 to the power of 5, let's say divided by 4 to the power of 1, I'm just going to use a fraction because that's mostly how they signify anyway that they're dividing, because remember, it's technically dividing, right? 4 to the power of 5 divided by 4 to the power of 1, that is going to be equal to 4 to the power of 5 minus 1, which is 4 to the power of 4. And then we just went over the product rule, and then the power of a product rule. This one's a little bit interesting, where if you have a term, let's say 9 to the power of 2, and you know that 9 is equal to 3 times 3, what you can do is you can take the exponent and distribute it to both of those numbers, and it'll still be equal to 9 to the power of 2. Yeah, this is a true statement, by the way. And then, yeah, the power of a quotient rule is when you apply the exponent to both the numerator and denominator. Let's say I have 1/2 to the power of, actually, no, not 1/2. I'm going to choose something better. Okay, yeah. 2 over 3 to the power of 2. This 2 applies to the top and to the bottom. So this is going to be equal to 2 to the power of 2 over 3 to the power of 2, which is equal to 4 over 9. And then, as usual, we have the negative exponent rule, which is that reciprocalization rule I was talking about. I think I should quickly go over the fractionalization rule just to be completely confident with you guys. So the fractionalization rule, or fractionalization exponent rule, is when you're combining square roots and exponents. Excuse me. So remember how I said the square root of x is equal to x to the power of 1/2? This is sort of like a derivation of the power rule, the product rule, where it's like you're multiplying stuff, kind of. If you had, say, x cubed and x cubed is getting square rooted, that is the same thing as, oh, I don't have any room. I'm just going to clear everything. Okay. Yeah, that's way better. X cubed square root of x cubed, that is equal, remember, this square root is equal to a half exponent. That is going to be equal to x to the power of 3 over 2. Or in other words, it's going to be equal to x to the power of 3 times 1.5. Because it's like it's as if we took the square root and then turned it into an exponent that can sort of play along there. If you want like the easy version, if you have a fractional exponent like x to the power of a and b, a is the exponent and then b is the square root. For example, if you had x to the power of 3 over 4, then 3 would be the exponent and 4 would be the square root. So that would be equal to the square root by factor of 4 of x to the power of 3. Before we move on, I highly suggest screenshotting this slide or taking a picture of it. This is a good chart that you should keep with you guys in general. So I'm going to give you 5 seconds. 1, 2, 3, 4, 5. Done. And we are going to move on. Here is some practice that I made for you guys. I'm going to give you guys 3 minutes to do it, starting now. All right, everybody, 3 minutes are up. So let's come back and check out these questions. So, first one, that is going to be, it's a negative exponent. That means that we have to, now the thing about negative exponents is that you don't have to look at it purely as reciprocalizing. You can look at it as simply moving up or moving down. So, if you were to, just isolate the 3 to the power of negative 5, you can move it up, and now it's 1 to the power of, no. Okay, and now it's just 3 to the power of 5, over 1, but you don't need to put the over 1 because you know about that already. Now you can do that in this equation as well, where you don't have to, you can just move it up simply. So now that turns into 3 times 3 to the power of 5. And remember the product rule where we add exponents. So this is like an invisible exponent 1 there. That's going to be 3 to the power of 6. That is a simplified one there. Now for this one, this is pretty simple actually. It's x squared, right? All you have to do is take the square root, turn it into its exponent form, which is going to be 1/2. And then 2 times 1/2 is equal to 1, right? So it's x to the power of 1. It's just x. Now the next one, this one, you have to do the fractional rule. So remember, exponent on top, square root on bottom. So this is going to be y to the power of 5 over 4. See how exponent is on the numerator and then square root is on the denominator? Now the next one, some of you might be thinking, how do we simplify this? Because there's not the same base number. We have 2 and then we have 4. Here's the thing, 4 is an exponent of 2 because 4 is equal to 2 to the power of 2. If you convert it into that, this turns into 2 to the power of x times 2 to the power of 2. And if you use the product rule, this turns into 2 to the power of x plus 2. Now the next one, so you can do the product rule simply right here. It's not the product rule exactly. Let me see if I can. Okay, wait. What is it called? Yeah, okay, it's called the. Oh no, okay, that one was the This is the power of a product rule. So this one, we can multiply the exponents over here. We'll get 2 to the power of 4. It's equal to 16. Now, the next question is literally the same thing, actually. It's no different at all. It's just, you have to do this part first, and then it turns into 2 to the power of 4 anyways, so that's just going to be equal to 16. Last one, this is going to be the division rule, where we have to subtract it. So there's going to be like a power 1, imaginary 1 down there. And then all we have to do is just do 10 to the power of 3 minus 1, which is going to be 10 squared. If you guys have any questions, you can raise your hand or we do have some questions. Mahit, do you have a question?
I was asking So what happens if you did 2 to the power of 2 to the power of 2 to the power of 2? Just like what you did in that one. Question number 6.
Yeah, it's not different actually from question number 5. It's just that the parentheses make it seem more complicated, but they're not different in any way, really.
So if you're saying 2 to the power of 2 to the power of 2 to the power of 2, then you're saying this is 2 to the power of 2, and then you're saying that's 2 to the power of 4, and then whatever that is, then you're saying 2 to the power of 16.
Yeah, pretty much.
But why do you always have to solve those exponents inside first? Why couldn't you say, oh, this is 2 to the power of 2 here first, and then after you said that was 4, then you could erase that to the power of 2?
Because first of all, you should speak a little bit slowly so that your fellow students will understand you. And also, you do need to consider parentheses, and parentheses are actually what make the rule possible. If there's no parentheses, then you can't do the rule that I just showed you, where you can multiply the exponents together. In the 6th question, it's sort of like the exponents are being forced together. And unfortunately, we're gonna have to move on to the next person. So yeah. Tejas, you have a question?
Thank you.
Are there proofs on the SAT?
Nope.
Okay, thank you.
You're welcome. Okay. Now, when dealing with exponents, you're also going to have to deal with extraneous solutions. Now, what is an extraneous solution? It is a solution that seems like it exists, but actually it doesn't. Let me show you. So in the first question, they ask, what is the solution to the given equation? Now we have a normal side and then we have a square root side. You might think, okay, well, maybe we should square both sides so we get rid of the square root on the right side. So if you do that, it's going to become x minus 12 squared is equal to x plus 44. And then if we just multiply this out, then we get x squared minus 24x plus 144 is equal to x plus 44. And then if we just subtract as usual, we get x squared minus 25x plus 100, which is equal to 0. And then I'm just going to erase this so we have more space. I'm going to do my trusty butterfly method. 1, 1, 20, and 5. If we apply a negative to both of the factors, then negative times negative, it is still going to be positive 100, but now we're going to have a negative addition. And if you cross multiply and then add them, you get negative 25, which is equal to the middle coefficient. So that means that this properly splits into x minus 20 times x minus 5. Now the problem here is that you might think, oh, well, the solution has got to be 5 and 20, so it's got to be D, right? No, not necessarily, because what happened is we squared both sides, but when you square something, you actually add an extraneous solution, or you possibly add an extraneous solution that seems like it works, but it actually doesn't. In order to figure out which one's extraneous, you need to plug both of the solutions back into the original equation. So let's do that right now. If we do x is equal to 5 and we plug that into the original equation, what do we get? I'm just going to write it down here. We get 5 minus 12 is equal to the square root of 5 plus 44. What does this turn into? 5 minus 12 is negative 7, and then we have the square root of 49. 49 is equal to 7. Oh no, we ended up with negative 7 is equal to 7. This is false. So 5 is actually the extraneous solution. Now, if we try 20 instead, let's see how that fares. We get 8 is equal to 8, which is true. So B is the correct answer, not D. Duthi, you have a question?
Yeah. So, hi, can you hear me?
Yeah, I can hear you.
Okay. So my question is, does extraneous solutions excuse me, sorry.
No worries.
Does extraneous solutions normally mean like solutions that are false, like that do not equal each other?
Extraneous solutions are actually false in the real world, but because of square roots and how they're just kind of weird, they accidentally get created. And because they're accidentally created when solving, we call them extraneous solutions.
Okay, so
They are wrong, yes.
okay, but if we do get like in a problem type, we would have to like put it when it asks for an extraneous solution, you should select the number that gives you the problem, right, to make it true.
Are you asking if there's going to be questions that explicitly ask you for the extraneous solution?
Yeah.
No, they will never. I don't think they'll ever ask for the extraneous solution.
Okay, thank you.
No worries. One thing I want you guys to remember, this extraneous solution thing, it occurs usually when you are exponentiating by an even number, such as 2, 4, 6, or 8. If you're doing it by an odd number, it's not going to, it usually will not have an effect because odd exponents will not change the negative or positive values. For example, if you did negative 2 to the power of 3, then you're going to get negative 8. You're not going to change anything because that is negative 2 times negative 2 times negative 2. That is 3 negative signs. So it is going to be negative. And then positive, same thing. So let's take a look at the second question. What are the possible solutions to the given equation? I'm just going to rewrite that because at the time I wasn't able to get a proper square root. But yeah, a cube root of x is equal to 2. What we're going to do now is we are going to exponentiate the entire equation by 3 and say x is equal to. Now, some of you might say, oh, but when we square root or exponentiate, we need to put a plus or minus, right? No, we don't need to put a plus or minus. First of all, because the plus or minus only you need it when you are square rooting something. And second of all, you only need it when it's done by an even number. If it's a cube root, then you don't need the plus or minus. So in this case, it's just going to be 2 to the power of 3, which is equal to 8. So B will be the correct answer. Now, what about the next one? What are the possible solutions to the given equation? We are going to cube root both sides to figure this one out. So on the left side, it's going to be 2x minus 3, which is equal to not positive 3. So if you didn't know, the cube root of 27 is equal to 3 because 3 to the power of 3 is equal to 27. So it's like a reverse, right? And negative 27, since we're cube rooting it and it's an odd number, we can still keep the negative actually. So this will be negative 3. We add 3 to both sides. We get 2x is equal to 0, and therefore x has got to be equal to 0. A is the correct answer. Now the last one, this is an even exponent question, right? So we're actually gonna have to put the plus or minus in. If we quad root this, I'm pretty sure they don't call it quad root, but I'm just gonna say that. We get x minus 8 on the left side, and then the quad root of 16 is going to be equal to 2. and we have to put the plus or minus 2 because this is an even square root. Sorry, no, this is an even root. It's just, sometimes when it comes to roots, you've been saying square root so many times you think that's the actual name of the function itself, but it's actually just root. So yeah. We get x minus a is equal to plus or minus 2. So x is equal to 8 plus or minus 2. This will give you the results. Oh, my bad. Seems I forgot to put a 1 there. Okay. You're going to get the results 10 and 6. So D is the correct answer. Seems like we have some questions. Tejus, what's your question?
Oh, I didn't lower my hand. Sorry.
Oh, okay, no worries. Surya, do you have a question?
Yeah, I was just wondering, could you plug in this answers into the equation and get your answer?
Yeah, you can totally do that. However, I wouldn't recommend it because it's gonna take a lot of time usually, and it's better to figure it out yourself. But yes, you can plug the answers in. That applies to pretty much every question, actually.
Okay.
No worries. Excuse me. Okay. Oh, it seems it's 9 o'clock already. I guess this will have to be, or at least the last slide will be our last slide of the day. In that case, as usual, if you guys have any questions, you can contact me on WhatsApp. I've provided my phone number and email to you guys, and you can find me in the WhatsApp group if you have any questions. And you should make use of that resource chart that I sent to you guys. I highly recommend it. Remember, practice is pretty much the only way you're going to improve with the SAT. All the teaching that I'm teaching you guys, sure, it's going to help, but it's not going to be helpful if you just keep on doing practice sessions without practicing by yourself. It's like a sort of psychology thing where when you do it by yourself, it's just better. Like, for example, getting tennis classes is helpful, but you need to apply that with your own practice. So yeah, that's pretty much all I have for you guys. And yeah, I'll see you guys later. Oh, and if you have any questions, you can stay back a little bit. Sanvi, what is your question?
Yeah, where can we get the recordings from the past lessons that we may have missed?
I think that they're on my YouTube channel, which TANA controls. I'll try seeing if I can put the YouTube channel in the WhatsApp group. Vedant, do you have a question?
Yeah, for the Google Sheets that you posted in the WhatsApp group, will that be you continue to add on the practice, or is it just the ones you sent the links so far?
Those are just the links I sent. I don't plan on adding any more practice, but there's plenty of good practice resources online. And honestly, if you get a couple of practice books and the Barron's book, that's gonna last you a really long time.
Okay, thank you.
No problem. Okay. Vedant, do you have a question? Oh wait, no, I just answered Vedant. Harsha, you have a question?
Do you mind sending the link for the Google Sheet one more time in the WhatsApp group?
Yeah, sure. I mean, if you scroll up, you should find it, but I'll try sending it after the class.
Okay, thank you.
No worries. Saranya, you have a question?
Yeah. So this is regarding what we did today. When is it the right time to check for extraneous solutions?
Yeah, the right time to check for extraneous solutions is when so sometimes you're gonna have both sides of an equation that one's gonna be normal, the other one's gonna be square rooted. If both of the sides of your equation have sort of unequal playing fields where one is neutral and then one square rooted, or one is neutral and one is exponentiated, and then you're trying to balance them so they're on the same level, that is what creates extraneous solutions. Extraneous solutions don't happen if say both sides of the equation are to the power of 3, you're not going to create an extraneous solution if you neutralize them and bring them down to a power of 1. But if both of them have a different power, like one is a power of just 1, like neutral, and then the other one's like a square root, like I said, that is what creates extraneous solutions.
All right, thank you.
No worries. Seems like there's no more questions, so bye guys, have a good time, and I'll see you on Wednesday.